Hi guys, my name is Chip Armstrong. I'm an associate instructor at the Wyoming School of Horseshoeing. My co-instructor is Lonnie Falk. We've just stressed out this thoracic limb to show you where the muscles and tendons all connect to each other, and to show you how the actual thoracic limb attaches to the horse's body. The horse's front limb does not have any ball and joint sockets. It's all attachment of ligamentous tissues. This right here and up in here, and it attaches to the rib cage and holds the entire thing together as a unit, like a bunch of rubber bands around a bundle of straws. One thing in particular, the horse has the ability to sleep standing up, and the reason that he has the ability to sleep standing up is because there's a series of tendons, ligaments, muscle bellies that enable him to lock his front legs. Biceps brachii. It attaches right here at the bottom of the scapula, and it runs down to the top of the radius. And so when this locks up, it'd be a straight line like this. Obviously this horse's leg is folded, but if he was standing straight up and down, it would enable him to lock this portion right here of his leg. There are other factors that are involved with that. You can see the scapula here and the rib cage here. The serratus ventralis are the ligaments that attach these the scapula to the rib cage, and that's what enables the horse's front foot to maneuver as much as it possibly can. You can actually turn 90 degrees out on a horse's front foot, whereas on the hind limb you can't because it's a ball and socket joint. Okay, well, what we're showing from behind here, what my fingers are on right now is the superficial flexor tendon. Can you see that? That's superficial flexor tendon right here. And then the deep digital flexor tendon runs inside of the collar right here, the manica forium. And it slides in and out independently of the superficial flexor tendon. The deep digital flexor tendon is shaped kind of like an oval, like a football, if you do a cross section of it. Whereas the inside of a superficial flexor tendon is shaped more like a piece of celery or rhubarb. It's kind of like a slide that it glides in and out of. And we were just playing with that with the extensor tendons, and we were showing basically how the deep digital flexor tendon folds a digit like this, and the superficial flexor tendon folds the entire limb. Can you pull on that, Lonnie? Pull on that. See how it folds a digit only? And it slides in this manica forium, which is where my finger is. Okay, so there are 4 tendons that run down the front of the leg. 2 of the tendons will attach to the coffin bone, and 2 of the tendons will not. So the main or common extensor tendon, which runs down the front of the leg and down here to the extensor process, and on this is the coffin bone. It's a porous surface for the attachment of the lamina and the nerve endings, but this is called the extensor process right here, and this is where this tendon is running to, and all that extensor process does is pulls that foot back out straight like this. Okay, the deep digital flexor tendon, which is the one closer to the bone and the one that's shaped like a football, runs through the superficial flexor tendon, and it goes all the way down to the bottom of the foot. This would be the bottom of the foot. This is called the semilunar crest of the coffin bone. This is the widest point of attachment for the deep digital flexor tendon. The tendons work opposite of each other Obviously, one extends, the other one contracts or retracts the foot. Okay. Um, the common extensor tendon is called the common extensor tendon because it's common to P1, P2, and P3. The deep digital flexor tendon is only tendon that runs to the coffin bone on the bottom side at the semilunar crest. The superficial flexor tendon attaches to the top of P1, top of P2, but it does not go to P3. This is the horse's knee. We call it the carpus because it's equivalent to our wrist. The bones are the same as in our wrist. And the horse's true knee is actually in the hind limb. The scapula is a flat bone for a wide point of attachment of ligamentous tissue. It has to be extremely strong so the horse can maneuver and actually stretch out. The cannon bone on a front foot is more round and it's a little bit shorter than the hind cannon bone, and we can get into that later as well. A front foot is shaped like a circle because the horse bears 60% of his weight on the front limbs, so that foot is actually designed to be a pillar that the horse can balance on. Whereas on the hind limb, when we get to that, it's also called the pelvic limb. We'll note that the foot is shaped more like a shovel, like a spade shovel, and its main function is for propulsion. The cannon bone of the hind leg is more of an oval shape as well, more like this instead of like this. If we take a look at the hairline, it basically will tell us if the foot is trimmed properly. It will basically tell us the shape of the coffin bone. The shape of the coffin bone dictates everything that we do. So when we shape a foot, we shape it to the coffin bone. When we shape the white line is shaped to the coffin bone. When we shape the hairline, we shape the shoe and the foot and the white line and all the trimming to match the hairline, which matches the white line, which matches the coffin bone.